Stanford University.
Okay, welcome to Stanford CS 193P. Today we're going to continue our lecture from last time. We're going to talk a little bit more core data stuff, and we're going to look at the code that's generated by Xcode for those custom subclasses of NS-managed object. That's what we talked about right at the end of the last lecture, how to do that, both to how to do it from scratch and then how to do it with this copy and paste mechanism after you have things created. And then we're going to go talk about how you actually make fetches, how you query all these objects that you created in this nice core data database. You want to query them, and because we got this underlying nice database and query language, we want to be able to use it at the object level. So we're going to talk about how to do that. Then we're going to get into how to hook up core data, all these objects that you build, with table views. Because obviously if you have a huge database, a real great way to look at it is to put the data into tables. Okay, and you want to make that really easy, so we're going to go through that. And then I'm going to do a demo that does exactly that. We're going to build a little Flickr. We're going to get some data from Flickr, as we are wont to do in this class. And we're going to throw it into a nice core data database, and then we will build a table view to query it. All right, so this is back to continuing what we had on Tuesday. What we talked about generating your custom subclasses in Xcode, and we also talked about copying and pasting the things over. So what does that code look like? When I do that copy and paste, or when I generate it, what's it going to create for me? And so there's two sides to this, the header files and the implementation file. And so here's what the header file is going to look like. So I put two header files actually up here, photo and photographer. Those are the two entities that we created on Tuesday. So you can see that mostly what gets put in there is just @ property retain for each of the things in my data model. Okay, and you can see that the type of it is appropriate to what kind of object that is. Like our thumbnail URL was a string, so it's an NS string. Thumbnail data was an NS data, or was a binary data type, so it gets NS data. And then who took is a photographer, right? It's a relationship to a photographer, so that's just going to be an NS managed object, which is going to be a photographer custom subclass in our case. And then same thing on the other side. We have photographer, if you remember that particular entity, and it only had one relationship. Well, actually, I think it might have had a name also, but at the very least it has this relationship photos, which is, points to all the photos taken by this photographer, and that's an NS set, just a normal NS set. Now, one thing I didn't show here, but that you'll see when you start doing the copy and paste and the generation, is that when you have an NS set-like relationship, it's also going to create some nice stubs for some methods you can use to add one photo to that set, for example. Because otherwise, if you wanted to add a photo to this set, you'll notice that NSSet star is immutable. Okay? So if you called NSSet, give me the list of photos, and now I want to add an object to that set, I'd have to do a mutable copy of it first, add it, and then set it back, set that property back. Do you see why? So it also will create some nice methods, add photo to photos, okay, that will do all that for you. It'll stick it in there, do all the mutability, et cetera. So you can do it with one line of code. You can add a photo to your list of photos. Okay? So that's basically what's on the header side. So what's on the implementation side of this? Okay, our custom subclasses implementation of these these properties, what does that look like? It's kind of interesting. It's going to introduce a new keyword that you haven't seen before called @dynamic. Now you might be looking at that other header file and you might have thought, oh, there's going to be an @synthesize in the implementation, which is usually what we do when we have an property in a header file. We @synthesize it, or we implement this header and getter ourselves. But in this case, we do neither of those things. Okay? Because what's going to happen here is NS-managed object is going to use the power of the Objective-C runtime, which is quite powerful, and we've barely skimmed the surface of what it really can do in this class. But one of the things it can do is when someone sends you a message that you don't understand, you can intervene and do something. Okay? Call whatever code you want to try and respond to that message. So that's what's going to happen here. When people start sending our custom photo subclass the getter thumbnail URL and trying to get that, this class is not going to respond to that. Okay? It doesn't implement that, because see, there's nothing in its implementation that implements that. And what's going to happen is the Objective-C runtime is going to get involved, and NS-managed object has some real smart code in there that will go and fetch that data and return the thumbnail URL. It's really quite cool the way it works. But if we don't put these @ dynamics here on the implementation side, then the compiler is going to complain. You have a property in your header file that you don't synthesize or implement the getters and setters for. You see why it's going to complain? So when we put @ dynamic in there, it just shuts the compiler up. It says, don't worry, we're going to handle it if somebody sends us that property setter or getter. And we inherit that handling from NSManageObject because our custom subclass photo or photographer is inherits from NSManageObject. Everyone cool? So that's it for the implementation. They're really, really simple. Even those little methods that I talked about for adding things to a set, same way. There's no actual implementation of those. This runtime intercepts those messages and does the right thing to make that work. So @ dynamic means I'll figure it out at runtime. And in this case, if you remember on Tuesday, we talked about value for key and set value for key as a way to set the values of your thumbnail URL and all that stuff before we did the custom subclasses. And if you didn't do a custom subclass, that's how you would have to do it. Well, you can think of NSManageObject just turns those properties into calls to value for key and set value for key as the setters and getters. It's approximately what it does. So what it lets you do in the end, though, is to use dot notation to access the properties of your photo object. So here, for example, I'm creating a photo object using insert new object for entity for name, which we talked about last time, right, in manage context. And so that creates me a photo object, and I want to set the attributes of it or get the attributes of it. So here I say NSString my thumbnail equals photo.thumbnail URL. Actually, that'd probably come back nil because I just created this photo, but it might have a default value, which you can set default values in the database using the data mapper. But anyway, so I just say photo.thumbnail URL to get, or I could say photo.thumbnail data equals, and maybe I call that Flickr fetcher image data for photo with URL string, you see? So I can set and get my properties that way. I can even set the who took, which points to a photographer, by just saying who took equals some NSManageObject I got out of the database by querying or using insert new object for entity for name, or however I get it, I can assign it there. And these relationships, by the way, like who took, if I set who took in a photo, it'll get added to the set on the other side, right? The photographer's NS set of photos will include this photo. So it's all magic. You don't have to worry about, oh, I got to set who took, and then I got to go over to my photographer and add it to its list of photos. This photo, no, you set one side, it sets the other. If you add it to the set, it'll set. If you add it on this side, it'll set a set. Now, adding it to the set wouldn't necessarily go the other way because it's too many relationships. It doesn't really know how to do that. Well, actually, that might not even be true, but it depends how you set your database up. But in any case, the relationships are managed for you in both directions. And if you set it to nil, it would then take it out. All right? So, so far, then, we've learned how to insert objects in the database and how to get their properties and set their properties either using value for key and set value for key or using these @ properties in our custom subclasses. So what's left to know how to do? Well, there's a few things, but the real important thing left to know how to do is to query, to go out to the database and say, give me all the photo objects that match some particular query criteria. And you do this by creating and executing these NSFetchRequest objects. Okay? So you create an NSFetchRequest object, and you ask the context to execute that fetch request for you, and it gives you back an array of the results. It's that simple. So how does that work? All right, well, when we're creating a fetch request, there's 4 important things that we got to think about specifying. Number 1, you got to say what entity you're fetching. Okay, you can only fetch one entity at in one fetch request. In other words, you can't have a fetch request that returns some photo objects and some photographer objects, right? When you fetch, you get all photo objects or you get all photographer objects. Okay, so we fetch a specific entity. So that's the number 1 thing, and that's absolutely required. You can't fetch without specifying what table or what entity you're trying to fetch. Number 2, very important also, NS predicate. So NS predicate is the search criteria. These are the things you're trying to match in the database that's going to cause those objects to be returned and not other objects. Okay? Now, this is an optional one. You can pass nil for the predicate in the fetch request. That means give me all the objects. Okay? So because if I don't specify any particular search criteria, it means I want all the objects. Next is the sort descriptors. This is actually an array of these classes called NS sort descriptors, and that specifies when you give me my results back, when this fetch matches a bunch of photos, here's the order to put the photos in. Okay? And you know, all of this is very smart in that if it can do it on the database side, it's going to do it over there. And that way you won't be pulling a whole bunch of objects over in memory, munging through their attributes to try and figure out how to sort them. It can sort as long as all the database keys involved in sorting in these sort descriptors is on the database side, it'll do it there. And same way when you fetch, if your fetch result gets a huge number of results, 10,000 results, it's not going to bring them all into memory at the same, at once. It's going to bring them in as you need them. Like if you had a table view, it's not until you start scrolling around that it's going to start faulting those things in. So that brings us to number 4, which is how many objects should we fetch at a time? Okay, what batch size should we use when we start faulting objects in? Like should we bring them, if we fetch photos and we match 10,000 photos, should we bring them in 100 at a time or 20 at a time or 1,000 at a time? And you have to make this decision based mostly on how big your objects are. All right, if you have really big objects, you're not going to want to bring in 1,000 at a time. If you have really, really small objects, it might be quite efficient to bring them in at 1,000 at a time as opposed to trying to bring them in 20 at a time. It's a little bit of a database theory thing. Most of the time we're going to pick pretty small numbers here, 20, 100, something like that. Probably for your homework, for example, really wouldn't matter. You're going to end up faulting most of the listing anyway. Or you can also specify the fetch limit, which is only fetch this many and just give up after that. So even if my fetch matches 1,000 photo objects, just bring in 100. I just want the first 100 in order of the sort descriptors, right? So these are the 4 things we have to specify when we create a fetch request. So what does that look like in code? So I just alloc init a fetch request. Then I just set these properties. The entity I set to the result of this class method of NS entity description, which is the same class you saw before that we use to insert an object in the database. This one's called entity for name. You give it the name of your entity, like photo, and you give it the manage object context you're going to want this fetch to happen in, and it'll return you an NS entity description. And then you set that property request.entity to do that. And again, that's required. Can't be nil. Then you got your batch size, your fetch limit, self-explanatory. And then you got your sort descriptors, which again is an NS array of sort descriptors. And you can imagine why that might be an array. We'll talk about that in a second. And then you've got your predicate. So I haven't really told you how the sort descriptor and the predicate. This code would only have one sort descriptor, right? I have an NS array with object : sort descriptor. And I haven't shown you the sort descriptors or the predicate. So let's look at those in more detail. So entity we talked about, and fetch size limit we talked about. So let's look at the sort descriptor. The array that you get back when you execute this fetch request is in order. Doesn't give you back an NS set of results that match your thing. It gives you an NS array. So it's in order, it's in a sorted order, and this is how you specify that order. This is how you create a sort descriptor. There's an init version. There's also one that returns an auto-released one that we use more commonly. It only takes 3 arguments. The first one is the attribute that you want to sort by. So if I was fetching for photos and I wanted to in order of thumbnail URL, which is probably unlikely, but I'm putting it here as an example because that's the only key I had last time in the example. So I just say init with that key. Ascending is whether you want them sorted, in ascending alphabetical order or descending. And then there's this selector. Now this selector is a selector that has to implement this, is part of this NS, it returns an NS comparison result. And you can look at the prototype for that in the documentation for NS sort descriptor. But basically it just takes another object in the list and it calls this method on it, and that returns an NS comparison result, which is either ordered ascending, ordered descending, or ordered the same. So these objects are either the same or before or after in the list. And there's a few different kinds of compares. There's localized case insensitive compare. That does what you would imagine. There's also just compare colon, which compare colon is nice because it can compare, like a localized case insensitive compare would only work on strings, right? If you specify as that your selector, then your key better be a string because there's no case insensitiveness of a date, for example. But if you just use the selector compare colon, it will work with dates. So it'll compare two dates, and you can see, is this date before or after this other date? Very useful for your homework, by the way. There's also a version of this that doesn't even take the selector as an argument, and the default is compare colon. So you're going to use that a lot. Yeah, I said that. Okay, so as I was saying before, some of these selectors, like compare colon and localized case insensitive compare, might be smart. In other words, they're not actually going to pull those objects all over into memory and start calling localized case insensitive compare on each one, because you can imagine that's going to fault in all 10,000 photos that you want. So instead, it's going to use some of the mechanism in SQL to return an ordered result by doing the compare on the database side. Everyone understand what I'm saying by that? And so that's all handled behind the scenes for you. So don't worry about that. And there's the class method that returned auto-released. We give a list. Okay, so this is why we give a list, an array of sort descriptors, because imagine you're sorting by name fields and you want to, or you're sorting a record of people and they have first names and last names, and you want to sort first by their last names and then secondarily by their first names, because you might have a bunch of Smiths and you want to sort them secondarily by the first name. So that's why you specify an array of sort descriptors. Often you only specify an array with one thing in it, but you could specify multiple if you had this kind of circumstance. All right, so NS predicate. So this is really the guts of the fetch request. This is really the thing that says which particular objects that you want. Creating one looks a lot like creating an NS string. Okay, for example, there's this predicate with format. Colon, it's got a format string, which kind of looks like an NS strings format string. But it's really not the same, because the semantics of what's in that format string are meaningful. So for example, this one, thumbnail URL contains %@, comma, server name. Okay, that's going to get changed to thumbnail URL contains server name. That contains means something. Okay, that word contains means that this string is contained inside of the other string. Right? And there's a bunch of different meaningful things you can say in the format of a predicate creator that decide how you're going to query. So let me give you some examples of those, just so you can get an idea. I can't go through all of them. There's quite a few, dozens of them. You want to look at the NS predicate object description essentially in the documentation, and there's a couple links there that'll actually take you to more documentation about predicates. But so you get an idea. Here, for example, is comparing one a field in the database, unique ID, to some string or something. Okay, so this is a direct comparison. It has to be equal. Here's an interesting one, in. Okay, in means, is this object in this too many relationship? So is it in that NS set? So you could do a query here where you ask, is this photo in the photos list of this photographer? You get that? So in is a magic word there. Here's greater than and less than. And here I'm doing dates. So I might have a property viewed, which might be an NS date property. And here I'm saying, is it greater than some NS date that I provide? Notice the %@ is just like a string. It's going to substitute whatever is after the comma in. So in this case, if I say %@ and I put an NS date there, it's going to put an NS date in. So that's how I could do greater than and less than. And then there's contains, and also contains has a little special, see that square bracket C after contains there, name contains square bracket C? That means case insensitive contains. Okay? And there's a bunch of regular expression matching stuff. It's just no end to how sophisticated querying. Pretty much anything you can do in a SQL query, you can do with an NS predicate object. Okay, but the important thing is to notice that you just create it with this predicate with format. There's a couple other ways to create it, but generally create it with predicate with format, and you have to know what kind of things you can specify, and by doing so you can query into your objects very powerfully. You can also build compound predicates. So I might want to have predicates that the date is greater than this and the name starts with the letter A or something like that. And you can build those kind of compound predicates using these and or predicates. So you can see here I have two predicates, predicate 1 and predicate 2. I put them in an array, and then I create an NS compound predicate. In this case, it's an and predicate, and that would make it so that it's querying into the database, and predicate 1 and predicate 2 would both have to be true to match and return an object. Does that make sense? So there's and or. Because some people get confused here because they're thinking they want to put the ands and ors inside the predicate format strings, but this is a good way to do it. All right, so let's put all this stuff together. So let's say we have photographer, and it's an NSManage object subclass, and that we've implemented, let's say we have a method that we've implemented in our custom subclass called photographer with name in manage context. And it's very common to implement a method like that in your custom NSManage object subclass. And what does that method do? It goes out and looks in the database to see if there's a photographer with that name, and if it is, it returns it, and if not, it creates one and returns it. Okay, so it's kind of a create if it's not there, and if it is there, give it back to me kind of method. It's going to return an NSManage object, which is the photographer that it either matched or created. So then let's say we say NSManage object star photographer equals photographer with name George in manage object context. Now notice I didn't say photographer star photographer, right? I said NSManage object, and that's okay because photographer is a NSManage object, inherits from NSManage object. I could have also said photographer star. That would have been fine too. In fact, I probably would have, but I intentionally put this NSManage object star because I wanted you to realize that it inherits from it. All right, so now let's create a fetch request that finds all the photos that this photographer has taken. Now, of course, we have a property that returns that in an NS set, but what we're going to do is we're going to fetch it instead, just to see what that code looks like. So we create the request. We set the entity to be a photo because even though we're finding the photos that a photographer took, it's photos that we want back, not photographers. So the entity that our request is going to go against is photos. I'm going to set my batch size to 20. I'm going to set my sort descriptor to sort by the title of the photo. Okay, title is a property on photo, let's say, and ascending, whatever. Selector will probably be just default to compare. And then the predicate, I'm going to say who took equals that photographer. Okay, so I'm just going to find every photo where the who took property in the photo equals that photographer. You see? So that's it. Got my fetch request. Now I have my fetch request in hand. How do I make it happen? How do I execute that fetch request? How do I get a whole bunch of objects? Very, very straightforward. We just use this method called execute fetch request in NSManage object context. Remember, NSManage managed object context is that magic place you go to do all things related to your data model. So I've got my request, and I just call this method. It's an instance method, execute fetch request. I pass the request, and I do one of these ampersand errors to see to get any errors back. Oops, that's an error right there. That should say NS error star error equals nil. And then this is ampersand error. So this execute fetch request will return nil if there's an error. It returns an empty array if no objects get matched. You see the difference? Okay. So if I do this and my predicate does not match any objects in the database, then I'll get an empty array, an array with no objects in it. If there's an error, then it'll return nil, and that error, if I passed it, will get sent. If it's successful, then it returns an NS array of NSManage objects. Okay? And if I have a custom subclass, it'll be an NS array of those custom subclasses. Okay? You can pass null, obviously, just like at any time. So what's some examples? So assuming the results above, this results that I called up here earlier, I might say something like NSManage object star photo equals results object at index 0. Okay, get my first photo in the list of photos that is returned. Or I might enumerate through all the results, right, for photo star photo in results. Now notice I say photo star photo, not NSManage object star photo. I better be sure that I queried into photos and that I have a custom subclass called photo. But usually I'm going to be quite sure of that. Also, I could say photo star equals results last object. And I actually told you about last object earlier in the course. It's a great method on array because it's different than object at index 0, because what happens if that array is empty and you do object at index 0? You're going to crash, right, because there's no objects in there. But last object doesn't crash. It just returns nil if there's no objects in the array. Okay, so last object is a real smooth way to make your code look good, especially if you're expecting a returned array with one match, like you queried on some unique property. That's very common. Like I say, make sure that if you're assigning these to photo stars instead of NS manage object stars, make sure that you're actually querying photos. Okay, otherwise you're going to get runtime errors. Okay, so that's it for fetching, creating objects, setting attributes. The last few things I'm going to talk about here, not really, you don't have to worry about for your homework, but deleting objects is straightforward, kind of. You just say delete object to the manage object context. The reason I say sort of on the straightforwardness is you have to be a little bit careful if you have relationships between objects, what happens if I delete a photo, does it get deleted from the NS set? If I delete, the NS set entirely, do the photos get released? Those kind of things. And there are lots of ways to specify those rules inside of core data, and you can look at those, and you probably want to understand those, but we're not going to go over those today. And in your homework, you don't have to delete any objects. You can just let your core data database accumulate objects. Question?
When fetching, is it possible to return an unsorted array and make it run faster, or does it not really?
Yeah, so the question is, if I'm doing a fetch request and I want to get my results not sorted, because I don't want the database to waste its time sorting things, can I do that? And the answer is yes, because that sort descriptors array is optional. Okay, so you can specify nil, it'll just return the objects in random order, unknown random order, which sometimes is okay, because you're maybe not displaying them in a particular order and you just want them as fast as possible. That's a good question. There's a ton more stuff we could talk about core data. We're only scratching the surface here. Things like optimistic locking. It has undo and redo, which is really cool. You can worry about things like staleness. What if I fetch an object and I've got multiple threads possibly working on that database, and how long am I going to allow that object to sit around before I refetch it to see if it's got new data? There's just a lot of stuff in here, but we kind of have done the basic stuff of inserting and querying and getting the attributes of it, and now we're going to talk about the table view connection. And you just need to know all this stuff is out there, and so if you're doing a more sophisticated database application, you can go out and understand all this stuff, but we're not going to cover it all here. Okay, time limited. Okay, so now got our fetch request. We want to hook it up to a UI table view. All right. Now you might think, well, that's pretty straightforward. I'm just going to query it. Got that NS array, and then I'll just start answering questions the table view wants, like how many things are in the array. That's .count, and load up the data, no problem. Array at object at index, whatever, load it up. But the problem is twofold. One, you want all that to be efficient. You don't want to be sucking things out of the database until they're actually needed, and so you want to make sure that it's being efficient in how the table view is interacting with the queries and the fetch that's happening, okay? And then the second is there's a lot of things like sections, creating sections for your table view that you found even with this assignment that can be kind of complicated, and it's extra code. You'd kind of like all that to happen by magic, right? Because if we're querying them from the database, if we had a key in the database that specified what section an object was in, well, presumably someone could just automatically put it in the right section and give me sections for free. And in fact, that's true, okay? There's an object in the class, an object in iOS called NSFetch results control, fetched results controller, and it hooks up a table view to an NSFetch request, essentially, in a way that gives you all that feature set for free, where you literally do almost nothing. All you have to do is create this fetched results controller, give it a fetch request, and then off you go, and it just does everything for you, okay? And that's what we're going to see in the demo today. Incredibly powerful. Makes your code so simple. You're going to look at the code you wrote in the last assignment, and then you're going to look at the code you have to write to do your new table views for this assignment, and you're going to be like, that is just amazing how much code I had to write last week. Because there's going to be maybe 2 methods per table view you have to write this week. So what does NSFetch results controller do? It's an instance. You create an instance of it. It gets hooked up to the table view. It serves as the UI table view's data source protocol answerer. It basically is its data source delegate, and so it answers all those questions. How many sections, how many rows, all that stuff. So, for example, if you had a fetch results controller, you could implement number of sections in table view by just saying fetch results controller sections count. Okay, because it has a method that gives you all the sections, and you could just do the count. And then cell for row at index path, you just have this magic method in fetch results controller called object at index that you give index path, you give it the index path, it'll give you the NS manage object that's at that, in that section at that row. So there's like almost no work for you to do. In fact, if you go to NS fetched results controller documentation, they're in the documentation, like at the beginning, is a whole bunch of code that you literally can just copy and paste into your table view that does all this. It's a bit like this code that you see here, where it answers all the questions. That's a little bit annoying, so I've done that for you for this assignment, and I'll show you that in a second. First, though, I want to talk about the fetched results controller, its delegate, because it has a delegate as well. And what that does is it will manage changes in the database. So if your core database changes, it'll automatically update the table view. So one thing you're going to find in your homework is if you change something in the database, some new Flickr data or something like that, your table view is just going to automatically update. You don't have to redisplay it, you don't have to reload it, it just magically works. And that's because your table view is going to be the delegate of the NS fetch results controller, and it's watching what's happening in core data, and anytime something changes, it updates any table view that is depending on that. It's really quite remarkable. So this class, sorry that slide was out of order there, but this class core data table view controller is a class that we put together last quarter, and all it really does is just a UI table view controller where we've copied and pasted the code from the NS fetch results controller. I'm sorry, it's hard for me to say. We've copied and pasted that code in that documentation into a class for you so that you don't have to do it, because we just didn't want you making copy and paste errors or whatever. You're free to go in and look at it. It's super simple code. Everything is just one-liner invoking the NS fetch results controller. So let me tell you how to use core data table view controller. And this is something, this class is like Flickr Fetcher. You'll download it and just drag it into your project. So how do you do it? So it saves you the pain of doing that copying. So all you really need to do to make this work is to set, the core data table view controller has a property called fetched results controller. That's its fetch results controller. You just got to set that property, so you are going to have to learn how to create a fetch results controller. I'm going to show you how to do that. And then it's got, the core data table view controller has a couple of properties for, in the table, what do you want the title to be and what do you want the subtitle to be? Like which properties in your object that gets queried from the database, title, name, what do you call it? Just basically what's the name of that property, because it needs to know that. And then you override a few methods in core data table view controller, like there's a method called managed object selected. Okay, you override that method. That gets called every time the user clicks on a managed object, right? Clicks on a row, and then you can do your push in there, right? You're going to push another view controller, you just do it in there. So you don't have to implement table view cell for row at index path. You just implement managed object selected in your subclass. So it's super simple to use. I'm going to do it today, so it'll all make a lot more sense when you see the demo. But first we have to understand how to create one of these NS fetch results controller. Very straightforward. It takes a fetch request, obviously. That's the request that it's going to control. That's the fetch that's going to fill up your table view. You need to give a managed object context, obviously, to do the fetch in. It has this argument section name key path. You see that's the third one. That is the key in the managed objects that says what section that managed object is in. In the table view sense, the sections in the table view. Okay, you can pass nil there and then you'll get no sections. It'll all just be one long table view. And of course, it'll be in order of whatever your sort descriptors are in your fetch request. And then it's got this thing cache name. The cache name is any arbitrary name. What's interesting about the cache is it actually survives launches of your application. Okay? Because it's caching results from core data. Your core data database survives launches of your application. It's a permanent database. So the cache also survives. Now, if your application runs again and you modify the database, well, the cache will get appropriately invalidated. Okay? But it's really very cool. So as the user works through and picks things out of the table view, scrolls down, etc., data is being pulled in from core data. It's getting cached into this cache right here. So you usually call the cache the name of your class or some unique string that specifies the cache for this particular fetch. You can say nil and it won't cache then. It'll constantly go back to the database anytime it wants to get the information. One thing about the key that says which section each managed object is in, if you want that to be efficient, you want that key to be stored in the database, right? Now, today I'm going to do that. I'm going to, if we have time, I'll get to do that key. I'm going to implement that key in my custom subclass of NSManage object, but really I'd be much better if I implement that key as a stored attribute in my data model. And the reason for that is then when it does the fetch, it can fault the objects in, 100 at a time or whatever, because it knows what section they're in on the database side, instead of having to fault them all in, run some code, and figure out what section they're in. So if you make that key that says which section, whatever, if you make that implemented in your custom subclass and not stored in the database, it's going to have to fetch all those objects to find out, how to arrange them in a section. So that's not so good. Okay, so that's our fetch results controller. How do we create the arguments to it? Here's a sort descriptor. I'm going to sort by title. And here's a fetch request. I'm going to release it because once I pass the fetch request off to create the fetch results controller, I don't need my request anymore. I set my request entity to photo, set the sort descriptor to that sort descriptor, do my predicate who took equals, and set my batch size to 20. Voila. So that's pretty much the entire code that you need to create a table view that will search for all the photos that were taken by a certain photographer. Okay? And that's what we're going to do today in the demo. So that's what's next. The demo is called Shutterbug, and what it does is it makes a query to Flickr to get a bunch of the most recently taken photos on Flickr, and then it presents a table view with all the photographers who took those photos, and when you click on them, it pushes another table view that shows you the photos that photographer took. Okay? So we're going to have two table views. They're both going to be core data table views. One's going to be photographers, one's going to be photos. We're going to have just a few lines of code in our application, did finish launching with options to do the Flickr query and populate our core data database. Create the photos and photographers in our core data database. You'll see that. And that's it. I'm not going to go the next step, which is you click on a photo and it presents the image. You could integrate your code that does that from this week's assignment or last week's assignment if you wanted to, but we're not going to spend the time doing that in class today. So your homework then is going to be to add a favorites tab to your Places app. So it's going to be a third tab. All your favorites information is going to be stored in core data. Okay? So you're going to have to decide what kind of data model do I need to store all the information so that I can do the querying that I need to do. One thing about the favorites tab, to be clear, and I underlined and bolded this in the homework assignment, but don't miss this part. The favorites tab shows you a list of favorite places, not photos. Okay? And then when you click on a favorite place, it shows you the favorite photos taken in that favorite place. All right? So even though in the user interface you click, yeah, this is a favorite photo. I like this photo. It's my favorite. So you're clicking favorites on photos. When you actually go to look at your favorites, it organizes them by the place they were taken. Okay? Because this is the Places app. So the new tab you're adding is favorite places, okay? And then inside is photos. So you have to do two table views there. Also, you're going to have to go back to redo your recents by querying core data instead of using NS user defaults. Okay? I just want you to get the experience of doing another core data table view. And then the last thing, we talked about file system last time. You're going to cache the image data that comes from Flickr for your favorites, and only for your favorite photos, in the file system. Okay? You have to create a file in the file system, put the data in there, and cache it. And if a photo no longer is a favorite anymore, then you have to take away that cache. So I want you to keep that cache up to date. I don't want you just always putting things into the cache and never taking anything out. So that way you have to learn how to delete files as well as write them out. Next week, on Monday, or on Tuesday rather, we're going to talk about blocks and multi-threading. So blocks is the way that you specify pieces of code that you want to run in another thread, for example, or that you want another method to run. You might pass it a block to another method and say, run this code for me. So we're going to talk about that, and then we'll do multi-threading. You can imagine what your assignment's going to be for next week is to get your Places app to stop doing things in the main thread and being blocked all the time. Okay? In fact, that's going to be the required task next week, is make your Places app so it no longer ever blocks in the main thread waiting for Flickr. Okay? And then on Thursday, we're going to have an important lecture, which is the final project guidelines. Kind of go over those. And then we might have some suggestions for final projects that you guys could do, et cetera. And that'll just be for Stanford. That's only inside Stanford people, so that probably won't even be on iTunes U. Okay, so let me do the demo, and then hopefully we can do this in half an hour. I think we can. This. All right, so I'm going to start from scratch again. So here I am in Xcode. I'm going to say create a new project. Now, when I create a new project, there's a very important switch for me to set right here. If you miss this switch, you'll be completely lost on this assignment. Okay, you have to click this switch. It generates some very important stub code for you. I'm going to create a window-based app, right? So I'm going to do my own application did finish with launching with options, and I'm going to make sure this is clicked, okay? So I click choose, and call this Shutterbug. All right, so here's Shutterbug. Make this bigger as usual. Okay, so let's look at the classes it created. There's our Shutterbug delegate, of course. And notice in resources now I have this magic thing here, which is my data model. So this should look familiar from last time's lecture. I'm going to zoom in a little bit here, make this bigger. So here you can see we have our entities and our properties, our attributes, and it's going to, as we build it, it's going to build a nice little graphical description of it down here. And so that's, we're just going to start off right off the bat and do that. So remember, Shutterbug shows photos by photographer, so I need two entities. I need photos, and I need photographers. This is going to be very similar to what you saw on Tuesday. I do that intentionally. So here it's created a new entity, right? It's called entity by default, but I don't want it to be called that. I want it to be called photo, okay? And its class is going to be NSManageObject. When I create a custom subclass, it's going to change this for me automatically to be whatever my subclass of NSManageObject is, but we'll do that in a moment. So let's add a couple attributes, okay? So we do that with this little plus right here. I say add attributes. The first one I'm going to do is I'm going to go image URL, which is going to be a string, which points to the Flickr URL for my actual image data. Okay, so there's that one. And then I'm going to add another one here. I'm going to call it title. That's also going to be a string. Okay, that's just going to be the title of my image from Flickr, whatever the person who took the photo called it. And then I have one more here called unique ID. Okay, which is exactly what it sounds like. It's going to be the unique ID for this photo in Flickr. Okay, and that's because if I run this app one day and then I run it another day and the same photo comes down, I don't want to create two objects in my database. So I'm going to have this unique ID so I can query it, find it if it's already in there, create a new one if it's not. All right, let's create another entity now. I'm going to create the photographer. So photographer. Okay, it also starts out as an NSManageObject. It's only going to have a couple of properties. It's going to have one name, which is a string. And it's going to have one, as we saw before, called photos, which is the photos taken by, minus. This wants to be a relationship. It's going to call photos. And it's going to be photos. So the destination, the kind of thing, relationship that it has, is to photos. And right now it has no inverse relationship, but it is a too-many relationship because a photographer can take many photos. All right, so that's the photos relationship. And then let's go back to photo and add a relationship to it, which is the other direction. So I'll call this one photographer, or let's call it who took so that we have the same naming we had in the other thing. Its destination is a photographer. It is the inverse. This one is the inverse now of photos. So you can see that it's got pointing to each other. And who took, however, is not a too-many relationship, right? It's a one-way relationship. So that's why this arrow only goes one way. Each photo only has one photographer who took it. Okay? So that's pretty much it for our model. Those are the only things we need to do this. One thing that's, when you create these models, you'll create an initial one, and then over time, you're going to find yourself adding attributes and things like that, and you're going to be doing this copy and paste thing. But today, I'm just going to show you how you take this model and create the custom subclasses. And if you recall, I said you got to click on one of your entities, okay, which is a little hidden thing you need to know. And then you can just say new file, because you're going to create a new class. But instead of Objective-C or UI view controller, it's going to be an ANIS managed object class. Okay, so I just click that. We'll just take the default of where it's going to put it. And I'm going to create one for both photographer and photo. Okay, I'm going to leave these clicked like they are. And finish. And here it is. It's created them for me. So here's photos, as promised. @ properties is all that's in the header file for that. Here's photographer. It has the two @ properties. And also, as promised, it has this thing for removing photos from that photo set, right? And let's look at the implementations. For photo, just the @ dynamics of those things. And photographer, same thing, just the @ dynamics. And for photographer, these methods down here are implemented as well, but we don't have to worry about the compiler complaining about them because it put them in a different interface thing here, different section of the interface, category of the object. So we're good here. The next thing I'm going to do is, let's save this. I got to get Flickr fetcher code and my core data table view controller code. So I have those right here. So here is my Flickr fetcher code, and drag that in. So I'm going to put that in other sources. It's not really my source. And of course, I'm going to click copy items into destination folder. Those of you who didn't do that suffered the pain of that. And then same thing, core data. Okay, these are the two files for my new core data class that I told you about that we're providing. Also going to copy those. And we can look at the API for that really quickly. So you can see this is the core data controller. It's a subclass of UI data table view controller. It implements the NS fetch results controller delegate. It has this very important property, which is the fetch results controller that's going to be managing the communication. And then it also lets you set the title and subtitle keys. And then it has methods down here, like managed objects selected, that you can override to do something when that happens, when a managed object is selected. So that's it. That's all there is to implementing this. Very straightforward. Okay, so let's start by adding the code in our application delegate that downloads the information from Flickr. Okay? So this particular Flickr, I added a method to it down here called recent georeference photos, and I'm going to upload this code so you can, it's a very simple method. And this just returns recent photos that have georeferencing, latitude, longitude in them. So I'm just going to call that method. I'm going to say NSArray Flickr, I'll call this photos. Let's say photos equals Flickr fetcher recent georeference photos. Okay, so now I got that, and I have to import Flickr fetcher.h. All right, so now I have the photos. So I'm just going to iterate. Remember, this is an NS array of NS dictionaries, just like the places thing was. This happens to be an array of photos as opposed to an array of the places. But I'm going to enumerate through it. I'm going to say NS dictionary photo info in photos. Okay, so for each one of those dictionaries of photo information, I need to create a photo in the database, right? So where should I put that code? I could put it right here, start calling NS entity description, insert object, but it's kind of not very object oriented to put that code right here, all right? So let's put this code somewhere where someone would expect to co-create a photo, which is our NS managed object subclass of our subclass of NS managed object, which is called photo. Okay, so I'm just going to go over and put it over there, which is right down here. In fact, I'm also going to move these things up to my classes because I don't really like them being down there. We'll close that. Okay, so I'm going to go to photo.h here. Okay, I'm going to call this method, it's a class method. It returns a photo. And I'm going to call it photo with Flickr data. Okay, and it's going to take a dictionary of Flickr data. It also needs one other important thing, okay, which is managed object context. Okay, because you can't create objects without a managed object context. And we're going to talk about where we're going to get that in just a second. All right, so this is the method. The job of this method is to create a photo object in the database if one doesn't already exist for that photo. Okay, so let's go ahead and implement that. Pretty straightforward. Put in our implementation here. Okay, so I'm going to start, because I like to program this way, I'm going to say photo star photo equals nil. And then at the bottom, I'm going to have return photo. And in between, I'm going to try and set photo, if I can, to hopefully be an object in the database. Now, before I can just go start willy-nilly creating this object, I'm just going to query the database using a fetched, an NSFetch result, fetch request. I'm going to query it to see if this photo is already in there. So I'm just going to create NSFetched fetch request equals NSFetch request alloc init. Okay, so I have a request. The entity here I'm talking about photo, creating a photo. So I'm going to say my entity equals NS entity description, entity for name, photo. And here's where we need this manage object context. So there's the context. And then the sort descriptors here don't really matter. Predicate does matter. So what is the predicate? I'm going to say NS predicate with format. And what I'm going to do here is look to see if there's already a photo in the database whose unique ID is the unique ID in this Flickr dictionary. Make sense? So I just say unique ID equals %@ Flickr data object for key, and the key that's in the Flickr dictionary is called ID, which is kind of unfortunate if you tried to have that be your you don't have a database attribute key called ID. Okay, it doesn't work very well. Okay, it gets kind of confused. Yeah. Oh yes, you did. I did. Thank you. That's why you're all out there, to catch these kind of errors. Okay, so that's a request that will go out and find that thing. So all we need to do is execute that. So I'm going to create an NS error here, set it to nil, and then I'm going to say I'm going to set photo actually equal to the context, execute fetch request, that request. Catch the error there. And so if this worked, if it was able to find that photo, then this would come back. Oops, sorry, one more thing we need to do. What does this return? This returns an NS array, so we need to last object. Okay? So if that array comes back and it has an object, if it has any object in it, it shouldn't have more than one because this is the unique ID. And so it's just going to return that last object. If the array comes back empty, then this is going to come back, the photo will still be nil. It starts out nil, it's still going to be nil. So what I'm going to say is if there was no error, okay, error, and the photo is still nil, in other words, that didn't find a photo, now I'm going to create a photo. Everyone see what I'm doing here? So I'm going to say photo equals, and remember the way we create objects in the database is with this entity description thing, insert new object for entity name. It's a photo in manage object context, okay? So now this is going to create a photo. If it fails, it'll come back nil again, okay? Almost never going to fail, but might. There's no way to get the error, by the way, here. So now that I have a photo, I need to start setting these attributes like the unique ID equals the Flickr data's object for key ID. And how about the photo's title is Flickr data object for key, I think it's title. And then the image URL, I'm going to need to go to Flickr Fetcher here to get that. Image, what's it called? URL string, yep, for Flickr info, Flickr data, format, Flickr, fetcher, was it photo format? Yes, large is good. Okay, so I got all that. So I'm in good shape here. The only thing I don't have set right now is who took, right? So I've set all my attributes in my photo that I just created, but not who took. So how am I going to set who took? Well, who took, that value for that attribute is a relationship. It's a photographer object. So I need to create a photographer object in the same way that I'm creating a photo object here. So where should I put that code? I'm going to put that in photographer subclass, right? And in fact, it's so similar to this, I'm going to copy and paste this and then edit it because for time constraints here. So let's go here and put it here. This one, though, is not photo with Flickr. It's photographer with Flickr data. So let's put that in the header file as well. Okay, now let's go change the things that are different, though. Okay, so fetch request the same. Okay, the entity here, though, is photographer because we're doing photographers. And we don't really have a unique ID for photographers. We're going to say their name is unique. Okay, if photographers with the same name are the same photographer for the purposes of our demo here. And owner name happens to be the key in Flickr photo entry for the name of the owner. Okay, so we execute the thing. That's fine. Probably would be better code if we call this photographer instead of photo. So let's fix that here and here and here and here and here. And then also we're inserting a photographer. Now the photographer, the only attribute it has besides that relationship is the owner name. So that's all we need to do there. And it has the property which is the photos taken by this photographer. Sorry, that in there too. But that we're going to set on the other side. We're going to go set that in photo, and that's going to automatically set it on this side, so we don't need to actually set it here. Okay? So hopefully I haven't made any mistakes there. We'll see. Oh, maybe this one, request for name. Oh, okay. Didn't we? Sorry, where? Oh, this. Photographer. Okay, that's still not right, though. What are we doing here? Oh, yeah, that's it. Sorry. Thank you. Okay, looking better. And the H file. Now, I don't know if copying and pasting makes it any faster there or not after you go find all the problems. Okay, so now let's go back over here. Let's fix the problems here. We have import Flickr fetcher. We got to import photographer. Okay, and now we can do who took here. And the way we do that is we say photo.whotook equals photographer with Flickr data, the Flickr data, in manage object context. Okay? So if I haven't made any other typos, now we've got a way where we're creating a photo object. It then creates the photographer. Both only happen if that thing doesn't already exist in the database. So here we've done both a fetch and an insert, so hopefully you've seen how to do both of those things. Now let's go back here to where we're iterating through all the Flickr photos that come back and call this thing. So I could say photo star photo equals photo. Let's make sure we import photo here, by the way. Photo with Flickr data, oops, photo info. Oops. Context. Okay, so now we need to provide the context, though, that all this is going to create. And where does that come from? And this is when I told you got to click that button, use core data for storage. Because if you don't, you're not going to get all this code down here. See all this? Managed object context. That's where we're going to get our context. Managed object model, which is a pretty powerful object as well. Persistent store coordinator that manages the SQL store. So we need all that stuff in order to do core data. So that's why you got to click that box. But the net of it is you get a managed object context here by saying self managed object context. Okay? And you're going to want to get that self-managed object context and pass it off to any core data table views that are going to be fetching from the database. Okay? It's kind of you can think of it as your main thread's managed object context, because you can actually have multiple managed object contexts. Each thread needs its own, okay, because it's not thread safe. But in your app, you're only going to have one. It's going to be for the main thread. You're going to do all the work in the main thread. Now, I don't actually do anything with this return value, okay, because all I'm trying to do is force the objects to be created. So I can just get rid of that. I don't need that. Okay, so we're halfway there. Right now, we've got to make, in fact, we could run this app right now. Hopefully it would run without crashing. And it does, but there's no UI, of course. We haven't done a UI. But it actually has updated the database. So if we went back here now and we commented out this stuff, this app would still work. Okay? Because we've already put all those things in the database. In fact, I'm going to leave that commented out, and we'll see if it works when we create our table view. Let's see if it finds any data in the database. All right, so let's talk about our view controller. We need two view controllers here, one to show the photographers, one to show the photos. Okay? They're both really straightforward to implement. So let's go do it. So I'm going to call one. These are both going to be subclasses of core data table view controller, this code I'm giving you. So I'm just going to say it's a subclass of NSObject and then change the superclass. I'm going to call this one photographers table view controller. Okay. Oops. So here's our photographers table view controller. I'm going to make it be a core data table view controller. Oops. I did something wrong there. Core data controller.h, sorry. And this, I put it in the wrong place. This is UI kit. Okay, yeah, what happened there was when I created that new file, I needed to be in the part that said UI or iOS, basically, classes, not Cocoa classes, which is the Mac. Okay, so what do we need to do here? This table view controller that is the photographers, it really only needs one thing to do its job. It needs the manage object context. Okay, once it has the manage object context, it's just going to go look in that context, that database, and find every photographer it can find in there and show them all to me. Okay, so my initializer here is just going to be init in managed object context. And it's going to take an NS managed object context as its argument. Okay, so that's going to be my initializer. So let's go implement that. Okay, so all this needs to do in its initializer is create that fetch results controller. Okay, that's the only thing it really needs to do. Set the key for the title and subtitle too, but let's just focus on that. So how does that work? Well, we got to do our famous if self equals super. And init with style is actually the super class all the way up to UI table view controller. So UI table view style plain. All right. Return self. Okay, so as long as that goes okay, let's create our fetch results controller in here. So I don't forget anything in here. Yeah, okay. So all we need to do to create a fetch results controller is to create the fetch request that we need. So let's do that. That's NS fetch request. We've already done this once. Let's do it again here. NS fetch request alloc init. Thank you for the square bracket. So request.entity. So this is photographers. So I'm going to say NS entity description, entity for name, photographer. Right? That's what my table view is showing. And the context is the context that got passed into me. That's why you see I have to have a context to do this. Request.sort descriptors. I'm going to do an NS array, array with object. I apologize for the long line of code here. NS sort descriptor with key. I'm going to sort by name, okay, the photographer's name. Ascending yes. We'll just use compare as the method, the selector to use. The predicate, what do you guys think the predicate's going to be here? No volunteers? Huh? All of them, which is nil. Okay? No predicate means match everything. And so I want to match every single photographer in the database. And then fetch batch size, we're going to set to 20. Not a big deal because it's probably going to end up fetching most of the stuff in. And then we need to create our fetch results controller, not change type, controller. I'm going to call it FRC. And we just say NS fetched results controller alloc. And here's the init for that. It's init with fetch request, our request, our managed object context, our section name key path. We're not going to have any sections to start here, so I'm going to say nil. And cache name, my photog cache, whatever. Okay, so that's our FRC. I can release my request now because the FRC is going to take ownership of that. And now I just need to say self.frc equals FRC, and then I can actually release the FRC because the property is retained, so it took it. Okay? The only last thing I need to do is this self.title key. That specifies which key to use in my photographer to be the title in a row of the table view, right? Because I could have many, many keys in a photographer, and so I got to pick which one. I actually don't need to do this, believe it or not, in this case, because if you have a sort descriptor, it will use the key of your first sort descriptor, assuming that if you're going to sort by that key, that's probably the key that wants to show in the table. But I'm putting it in here because not all of your table views will that be the case, okay? It's a hint. So that's that. So let's see if I've made any errors here. Yes, I have. Self.frc. Okay, what's going on there? Oh, sorry. Self.fetched results controller. How about that? Okay, so that's that. The only other method that I need to implement in this class is managed object selected. Managed object selected, which is a method that's called, it's a void actually, which is a method in core data table view controller that gets called when one of the rows is clicked on, right? NS managed object star managed object. And I'm not going to do anything in that right now. We got to do what we always forget to do, which is back here. Let's create photographers table view controller. Create that here. Photographer table controller PTVC equals photographer alloc init. And then we're just I'm gonna do a UI navigation controller here. Navcon equals UI navigation controller alloc init. And then let's navcon push PTVC animated no. And window add subview, which I forgot last time. Navcon view. Okay. Oh yeah, that's it. Good call. Init with. We didn't give our managed object context. Init in managed object context. Self.context. Absolutely. That's exactly what happened there. Good call. All right, let's see if that works. Oops. Request. Oh, self.managed object context. I should look at my compiler in there. Oh, it works. It's a miracle. Okay, so here you can see we got all these photographers by name, and we click on them. Now, we're obviously not going to have time today to do the next thing, but I'm going to start on it, and we'll get as far as we can, and then I'll post the full code. So what we need to do here is just push another controller. So I'm just going to say new file. I'm going to go here, Objective-C class, do it the right way this time. This one's going to be photos by photographer table view controller. I think my names are long enough there. I think so. And this is also going to be a core data table view controller. Copy, paste. This one's init, is init with photographer. Everyone see why that is init with photographer? And interesting thing here, I'm not going to say in managed object context. And that's because the photographer has to have come out of a database, and so it has a managed object context. So I'm going to use its managed object context in order to query here. Okay? So that's this guy's right here. I'm going to use copy and paste, even though it didn't work so well for me last time, and change things. Oops. Copy and paste. Let's get rid of that. Okay, first thing I'm going to do at the beginning here is I'm going to get the managed context out of photographer. Okay, that's a method on in this managed object, is to return the context that it was in. I have to make a few changes here. Here I'm querying for photos. So I'm going to sort by the title. Really kind of questionable as to what to sort by there, and I need a predicate here. So let's do the predicate with format. And this predicate is quite simple. It's who took equals the photographer. Okay? And what else do we need to do here? This is title. I think I made notes of it here. I want to change this to my photo cache. I think that's a photo. I think that's everything. Let's see if it compiles. That was a good try. Well, I picked the right one this time, so we got foundation out of it, which is good enough. Okay, so the last thing we need to do is push. So let's do that here. We're just going to say photos by photographer star PTVC or something like that equals photos by photographer Alec init with photographer, and we need the photographer. Where are we going to get the photographer? It's passed to this method. Photographer star photographer equals photographer star managed object. Okay? So we're in good shape here. We just need to self.navigation controller push. Self.navigation controller push view controller. Why is that not working? Well, first let's do this real quick. Pound sign import photos by photographer. Okay, now let's try this, see if it has it better. Oh, okay. All right, self.navigation controller push PBPTVC animated yes. PBTVC release. All right, let's see if that works. This will really be amazing. Okay, so already amazing. Let's try, like I know a way to, let's go back here and reset our database. One other thing that we want to be sure to do here when we write to the database, here we're getting our Flickr photos, downloading them, is to save the database. Because remember that all writes that happen, all these objects that we're changing the attributes of, that's only going to happen in memory unless we write it out to the disk. So there's actually some code that was generated for you. If you scroll down here on save context, there's a method right here that will save the managed object context. So we can actually, especially if we're in our application delegate, we can save this with one line by just saying self save context. And you want to do the save, anytime you do a batch of changes. And clearly here we're doing a batch of changes. We're adding all these things from Flickr all at once. And that'll make sure that all that data gets written out and we won't have any problems with the application database being out of sync and crashing, whatever. So you want to make sure you remember that line. So you can see that this is doing a lot of things automatically for us. Putting the titles on here, loading things up. It's very little code to be able to query. And really, if you find in your homework that you're writing a lot of code, you're going down the wrong path. Okay, your homework should be very similar to this. Very, very little code. Init, manage object context, on your way. Most of the work that's done to make this work is done in creating your database properly, having the right attributes and the right relationships with things, and querying things. Okay. So I am going to post a couple of extra things that I don't have time to do today. One is I'm going to show you how to do sections, okay, which is basically 2-3 lines of code to do sections. I'm also going to show you how to search. So you can put a little at the top of the photographer, there's going to be a little search bar here, and you can start typing, and it'll actually search inside the list of photographers, which is kind of fun. And what's the other thing I was going to put in that code? I will put, I'll show case insensitive search, because look at this list. It's not case sensitively searched. You see how the lowercase a's are at the bottom? All right? So I'll show you how to make that work as well. So I'll post all that. That won't be posted until tomorrow afternoon because I'm going somewhere right now, but hopefully you won't be starting on your homework till then anyway. Thanks for bearing with me on this demo. It's quite complicated, but hopefully you got the idea. And good luck with your homework for next week, and we'll see you next week.
For more, please visit us at stanford.edu.